Alright, so this is the first part that we're going to run, and basically my intent anyway, is to travel around to each machine. I'm going to show you how to do it, and then I'm going to take one student over to that machine, and they're going to inspect a whole array of parts. You know, many parts that are all, in theory, made the same way. So I have a bin here of the parts. So we're going to go through and inspect the whole bin. Now, I'm not going to make somebody sit there and inspect all of the parts by themselves. As soon as you feel like you have a good handle on this machine, then we're going to rotate and everybody is going to move over to the other machine. As far as how we're going to sanitize all this equipment, I don't know. It makes sense to me that you just sanitize your hands before you touch this stuff, and then in theory, don't directly cough on any of this stuff. Don't lick it. Sounds reasonable as well. And whatever other parameters you want to put on that, but we are going to rotate through on different machines because to try to set up different jobs on each machine is doable, but it takes time. I want you to get a really good feel for what is a CMM and how does it do its thing. And that's what this exercise is all about. So with this first machine, we're actually midway through the program, and right now it's taking some scans on the ID of this hole right here. And obviously we have a pretty small probe on that. I think that probe it's metric, but I think it's 60 thousandths in diameter where it actually touches on this little ruby right here. And that probe is not capable of touching all of the features that we need to touch in this program all at once. So we're also going to do a probe change, and Zeiss calls these stylus systems. So the stylus system is from the scanning head right here down. So this is a stylus system. This is a stylus system that only has one stylus on it. This is another stylus system. You can see this is the one that we were just using, and it really does have a tiny probe diameter on it of only 60 thousandths. And the reason we had to do that is the hole itself is not very big. And if we look at the stylus system on the probe we just changed to, don't take those probes off like this. If you pull the springs like that, you'll damage. This is $15,000 from here to here, and you can damage it by pulling that straight down. So don't do that. If you do it just right, it's fine, but if you don't know what you're doing, it's expensive quickly. You see how that stylus doesn't really fit inside of that hole? I don't know if you can see that from where you are. All I see is a pull from my perspective. But that is that right there. So at the end of this, we are going to loosen up our fixture. So we have a little 9/64 Allen wrench. We'll take our part out. We'll put our next part in, and some of you might be wondering, hey, when you probe the inside of that hole, it's really important that that hole is oriented correctly. In other words, if we put this hole in there sideways, the probe won't be able to get in there. And, by the way, it'll crash on its way. Again, $15,000 right here, so it can get pretty expensive pretty quickly. So attention to detail is very important here, and also duplicating the setup, extremely important. So here we have a gauge pin, and this gauge pin came out of that blue cabinet over there. So occasionally we'll have to walk over to that blue cabinet to get whatever we need for our setup. That gauge pin goes in this hole, and notice that based on the design of this fixture, this can't rotate very far. Maybe you can't see it on the video, but I'm pushing it back. It only goes so far. I'm pushing it forward, and it only rotates a degree or two, not very much at all. I'm going to try to get that centered in between those 2 points as best as possible. And then I also have my location left to right. Is that coming across in the video? Yeah. My location is really important here too, because I need to come in and probe this side of the piston head. So for my location, I just have any old block of material that's flat. I happen to have this part sitting on the next machine, so I said, yeah, I'll use that part. I'm just using this as a flat surface right here. I'm going to butt the part up against it. And then I'm going to tighten this fixture down. Now, unlike with CNC, well, tighter is not better in CNC applications, but you can get away with putting parts a lot tighter in a CNC machine. On a CMM, tighter is definitely not better. All right, so you want to tighten the part until it stops, and then just a little more than that. So what do I mean by a little more? Like a degree or two more than that. So a lot of this class will be just getting the feel for that. Like, to some people it comes naturally, that's great. To others, it doesn't come so naturally, but after they have enough practice, they're close enough for the machine to find the part. Of course, we'll take that locating pin out of there before we run the program, and I like to just take this locating pin. It sits right there in that hole in the fixture, out of sight, out of mind. Leave my Allen wrench there so that way I don't lose it. And then on the computer side of things, we have a PDF here, and I'll zoom in on that a little bit. I'm not even going to bother reading this yet. I'm just going to come up here to where it says fetch data, and that looks like a picture of a piece of paper with a red Adobe symbol on it. And I'll hit fetch data, and this is actually the second part that I'm inspecting today. It's already saving to the correct location over here. I'm just going to name it 2-1. So the 2 is the part number. -1 is saying this is the first time I'm inspecting this part. So I'll say save on that. Do I want to open a PDF? No, I don't. And I'll close out of this. And down here in the bottom right, there's a little button that says run. All you have to worry about for today is you hit run and then start. And it is actually running the machine right now. So the first thing we're doing is coming down with our star probe. Whoop. In theory, the first thing we would be doing is coming down with our star probe. Right here, it's clear that I didn't fully put that star probe back where it wants to be. The star probe has 4 different balls that it locates on, so I didn't orient that correctly when I put it on there. The easiest thing for me to do in this case is just put the star probe back in its carriage, so that way this will grab that in a way that is calibrated and it won't damage it. So I'm going to do that right now. Don't mind the man behind the curtain on this. And right now I'm performing an automatic stylus change, and that'll go grab that probe properly this time. And I'll drive it back over to where the end of the last program was, at least roughly. Was right about there. And let's pretend we didn't see any of that. I'm coming back over here, hitting the run button in the software, and I say start. And now we're off and running. So I could tell something wasn't right as soon as it tried to touch the part, and the probe just kind of bent out of the way. The software actually was going to keep going. It was fine with that. So it just goes to show you that with a CMM system, like if it says that the part is good, there's a really, really high chance that the part is actually good. Because the chances of the machine telling you that all these different features on the part are exactly right within a really, really small margin is near 0. The opposite of that is not true. If the CMM says that your part is bad, it doesn't necessarily mean that your part is bad, because there are so many things in this system that could be going wrong. It's very likely that one of those other things, like where is the part position, is what's going wrong, and your part is actually correct. Now right here, the probe, it's kind of hard to see from the screen up there, but the probe is about to enter into this hole. And on the computer screen, I see that it says confirm probe aligned with hole. Now, why do I do this? Well, this is going to be your first time touching the machine. And if you misload a part by accident or you forget to put that gauge pin in there, we don't want to have this CMM rapid the tool directly through the part, right? So all this is saying is look at that, make sure that the hole is there, because when you press enter, that is going to come down and start inspecting that hole. So that's it. That's the first cycle. So when this is done, a dimension report is going to come up. We're going to save that dimension report, and then we're going to start the next cycle. And as the next cycle is running, then we'll review our dimension report. So right now it's putting that probe away. It's going to go grab our star probe again, because that's the first probe that it uses in the program. And then it'll park that star probe close to the part, but out of the way enough so that way the operator can load that feature. So who wants to be the first one to run this part? That's kind of funny. I was going to say thank you for volunteering, and I was going to point at you. You are off and running.